This isn't speculation. The evidence is real. Harvard astrophysicist Avi Loeb just confirmed that 3I Atlas may have shattered into 16 pieces, and the images are jaw-dropping. Just imagine a visitor from another star system, drifting through space for millions of years, only to arrive here and explode right before our eyes. Not in theory, not in rumor, but in data clean, hard, measurable data. 3I Atlas, the third interstellar object ever discovered by humankind, is rewriting everything we thought we knew about cosmic visitors. Before it came, we only had 2 Oumuamua in 2017 and 2 I Borisov in 2019. Both were strange. Yes, but this one is something else entirely. NASA and ESA confirmed its trajectory. The Hubble and James Webb telescopes have been tracking its every move frame by frame, hour by hour. And what they're seeing looks more like a slow-motion detonation than a comet's tail. 16 glowing fragments now streak across the void, scattering in perfect formation, a cosmic fireworks show. Silent but staggering. Each piece still glows with that eerie blue-green hue, like embers that refuse to die. Scientists are calling it a catastrophic breakup. But even that doesn't quite capture what's unfolding, because this isn't just a rock breaking apart. It's something far more deliberate, something that feels like it had a reason. So the real question isn't what broke, it's why and what made it explode. Might be even stranger than the explosion itself. It all started months before it broke apart with one impossible number. On July 1st, 2025, the Atlas Survey telescope in Chile picked up a faint streak of light moving against the stars. At first, it looked ordinary, just another icy traveler from the outer reaches of our solar system. But when astronomers calculated its path, the numbers made no sense. Its trajectory wasn't bound by the sun's gravity. It was coming from somewhere else. That's when the designation was given 3. I Atlas, the third interstellar object ever discovered by humankind. The 3 stands for its order of discovery, the I for interstellar, meaning it was born beyond our sun's domain. In all of human history, only 2 others have ever been found Oumuamua in 2017. And 2 I Borisov in 2019. Each one rewrote textbooks. But this new one, it was already starting to break them. Astronomers around the world turned their telescopes toward the coordinates, expecting a faint, predictable comet. Instead, what they saw was something brighter, faster, and far more erratic. It moved as if it were responding, as if it knew it was being watched. And yet, this third visitor was about to do something no comet in history has ever done. Then came the math, and that's where everything stopped making sense. As 3I Atlas got closer to the sun, it started speeding up faster than gravity should ever allow. It wasn't drifting anymore. It was accelerating, as if something was quietly pushing it from behind. Harvard's analysis called it non-gravitational acceleration, a motion that couldn't be explained by the sun's pull alone. The numbers were clear: a radial acceleration of about 1.1 times 10 to the -6 astronomical units per day squared, and a transverse acceleration of 3.7 times 10 to the -7. Translated into something human, it was speeding up by roughly 94 kilometers every day squared. That's insane for an object already moving at over 150,000 miles per hour. And the pattern wasn't random. The acceleration came in pulses rhythmic, measured, almost deliberate. Harvard called it non-gravitational acceleration. In other words, it was moving like something alive. And if that wasn't strange enough, its color began to change. The comet was turning blue, not gold. Not white deep. Electric blue. Astronomers were stunned. Comets usually reflect sunlight as pale yellow or silvery white, the glow of ordinary dust and ice. But 3I Atlas was becoming bluer than expected. Like something forged from metal. Not ice. Some suggested it might contain rare compounds, metallic crystals, or exotic ices that scatter light in ways we've never seen. Others whispered a stranger thought: what if the reflection wasn't natural at all? Imagine a comet glowing like a neon blade cutting through the night sky, a line of blue fire, alive and defiant. And yet, color wasn't the only thing changing. The numbers went wild. By October, the comet's mass loss had skyrocketed 6,000 times higher. As 3I Atlas moved closer to the sun, the heat began tearing at its frozen surface. Carbon dioxide and water vapor burst outward in violent jets, acting like natural rocket engines, pushing the comet forward through the void. This is called outgassing, a normal process for comets. But the numbers this time didn't fit the model. The energy required to produce that kind of mass loss was far greater than what a comet just 1 or 2 kilometers wide could possibly absorb. It was shedding nearly 2 million tons of material every second, a cosmic storm of gas and dust that defied basic thermodynamics. Harvard's Avi Loeb ran the numbers again and came to a stunning conclusion: to reach that rate, 3I Atlas would need an absorbing surface area 16 times larger than its actual nucleus. The only logical explanation it had shattered split into many smaller pieces, each one venting gas into space, like engines firing in sync. 16 fragments, 16 exhaust plumes, all burning together like a machine running at full power. But then telescopes saw something that changed the story completely. On November 9th, British astronomers captured a comet breaking every rule in the book. Their telescopes revealed a formation so bizarre, it silenced every observatory chat room that night. 3I Atlas had developed what's called an anti-tail, a stream of light pointing toward the sun, not away from it. That alone shouldn't be possible. But this one stretched nearly 3 million kilometers and held a strange geometric precision. It didn't look like scattered dust. It looked structured. Across the same week, several amateur astronomers, Michael Butner, Frank Niebling, and others confirmed the phenomenon independently. They detected at least 7 distinct jets erupting from the fragments, forming symmetrical, organized lines of plasma. They weren't random bursts. They looked aimed, controlled. Every photo showed the same eerie alignment, as if all 16 fragments were working together, firing in formation. And that's when Loeb asked the question no scientist wanted to say out loud. What if 3I Atlas isn't a comet at all? Avi Loeb didn't make that claim lightly, and he didn't say alien spacecraft. What he suggested was far more cautious and far more scientific. He proposed that technological propulsion could explain the strange data more simply than natural outgassing ever could. In plain English, if 3I Atlas were using thrusters, it wouldn't need to burn millions of tons of gas to accelerate. Just a few controlled exhausts at high velocity could account for everything we've seen: the non-gravitational acceleration, the rhythmic pulses, the organized jets. It's not about proving the extraordinary, it's about following the math wherever it leads. Because sometimes, numbers tell stories that physics can't yet explain. Are we looking at nature or design, something born from ice and dust, or something engineered to cross the stars? Because the next observation could settle that question forever. December 19th, 2025. That's when the truth arrives. That's the date when 3I Atlas will make its closest approach to Earth. And every telescope on the planet and above it will be watching. The Hubble Space Telescope will measure its ultraviolet spectrum, searching for the chemical fingerprints of ice, gas, and metal. Meanwhile, the James Webb Space Telescope will capture high-resolution infrared images, mapping its fragments or confirming a single, intact body. For the first time, we'll see whether 3I Atlas is 16 shards of frozen rock or one machine still holding its course. And after January 2026, the window closes. 3I Atlas will fade into the black, leaving behind only the data, the final echo of its visit to our solar system. Whatever it is, natural or not, it's a message from beyond. And the universe just handed us the mic. If you want to know what those telescopes find next, make sure you're here when the data drops. Stay curious. Stay critical.